Yes, I'm James. Hi. I've been a Java developer for about 10 years, and so recently I've been looking at what's coming up in Java 8. I've been a fan of the functional style of programming for a few years now. I started sort of with Scala around when it was 2.8 version, and I've even come to sort of love JavaScript, finding a way for its functional style, but we'll not talk too much about it. So Java 8's coming, and it's got Lambdas in it. It's released in 2 weeks, I think, or just under 2 weeks. It's been in preview for about 2 months, 3 months, 4 months, something, a few months. And they've done their final build, release counter build, and so it's got apart from Lambdas, there's embedded JavaScript and new date and time API. So for anybody that knows JodaTime, an API very much themed on the JodaTime API is coming into Java 8. So it's joined other languages like Scala, which has obviously got Lambdas being a functional language, but C#, not a functional language, but it has Lambdas. JavaScript, as I've already mentioned. PHP has got them. Even Visual Basic's got Lambdas. So I don't know what Java's been taking its time over, but so we are. So I don't know how many people have used Lambdas in one form or another. Probably using JavaScript, almost everybody, right? So remember anonymous classes, they look like that, and your swing code is decorated with unreadable code that looks a little bit like that, and they were a bit of a pain. So we've now got anonymous functions, and that's ultimately what a Lambda is. It's an anonymous function, and you can see there the arrow syntax, which I seem to have used the Scala arrow syntax instead of the Java one, which is a bit of an error. So hyphen greater than is the syntax of Java for Lambda, and that's how you define it. You can have it as a block if you prefer, multiple lines if you really want to. Obviously readability goes down the bigger your Lambda gets. So you define them, it's just an interface with one method that needs implementing. So there's an interface of one method that needs implementing, and that would be a functional interface. And they've introduced an annotation functional interface. And you can think of that a little bit like the override function. So if you put it on an interface, it will then, at compile time, check that you really have defined a Lambda function. So it doesn't actually do anything other than just checking, just like override will give you a warning if you've said that something overrides something, whether it isn't actually overriding anything. So a Lambda function is an interface with a single method that is implementing. And it's defined using the syntax round brackets with arguments, so you can have no arguments, which would be just a pair of parentheses. One argument is a special case, you can choose to omit the parentheses if you want to, and multiple arguments, and then an arrow and a body. So that's it. There's a little bit more to it than that. We can do some interesting things with Lambdas. So, anybody used Guava? So the big fans of functional style might have used Guava for dealing with collections and so on. So there's a little bit of using anonymous inner classes, filtering a list, and then transforming that list. So that can now be rewritten because these predicate and function interfaces that Guava defined were just single method interfaces. You can take that and turn it into that bit at the bottom. So already it's getting a little bit neater, even if you just use like a third-party library like that. And no change to Guava needed to do that, just like no change to your own code if you've got similar sort of interfaces. So, it would be a bit mean if that was all they've done in Java 8. and they have extended the API with a few extra bits and pieces. So we've got new package, Javautil Function, and that's got some basic functional interfaces like consumer and predicate and supplier and function. So basically these are the predicate's a special case because actually it's not strictly required, it's just a function that goes from T to Boolean. But, excuse me, the other two are just dealing with void and no argument functions. And there are a whole lot of other more specialized cases like a unary operator that takes T and returns T and so on. So then we've got, there's also Javautil stream, which is sort of parallel to the collections in a more functional style. A stream being something that you can iterate on, but you don't know how big it is. It's not got a definite end, it's just got a head, or potentially got a head item and a tail of other items. But that has a bunch of useful functions. So collections can be turned into streams just by calling stream on them. So then you can filter, you can map, you can flat map, you can reduce. And so you can take that bit of Guava we had before and use Jawbreaker. You don't really need Guava anymore, so there's turn it into a stream, filter it and map it. The other thing they've done is method references. So where I was using string value of just to implement my Lambda, that's a bit of a pain. You know, all we're doing there is taking a function that already exists. So, fortunately, you know how to do that. You can use a colon to get a reference to a method. So you can do that either on a class or an instance. And yeah, so there's an example of using the static value of method of string. Or you could define a formatter, perhaps, but then all you need to do is use the reference for that every time. So one of the things that people like to do with Lambdas is closures. So closure being returning from your method a Lambda function that has in its scope parameters and variables that have been created within that function. So obviously my closure there is a pretty crap example, but you're taking the x being provided into the outer method and using that in the scope of the returned Lambda so that you can just multiply by that x by just providing a y. So at the bottom there you've got how that could be used, so you can use them. So function, for example, has an and then method, so you can just chain lots of Lambdas together. So that one's turning, using my multiply by 2 and then adding that, turning it into a string with an answer. And so you can see the generics there working to turn the overall Lambda into a string. So the other thing people like to do with Lambdas is curry with them. So curry is a partially applied function. It's where you've defined your Lambda and you want to supply some of the arguments up front, but you don't want to supply all of them. So you might then, at different stages in code, populate some of those functions and chuck up the Lambda so that it can be reused over and over and over again. So you don't have to, you can do your calculation in place of some of the variables that don't all have to be done at the same time. So there's doing a bit of applying, but Java 8 doesn't support currying, unfortunately. So you can't do, well, you can do that, but you can't do it with the API out of the box. You've got to write it yourself. So that's a bit annoying, really. Currying is one of the most useful things about Lambdas. And it's a problem that Scala have had to get around to the same thing. So anybody that's used Scala will know that in order to get around things like that, there's a whole lot of classes or traits defined. So Scala defines function 2, function 3, function 4, function 5, and so on and so on and so on, with all the generic arguments you've got there. And then defines a method on those traits called curried. And through some Scala sugar, when you put an underscore after a method call in Scala, it uses that curried function basically to just to curry it. So we could do something similar with Java, but we have to write it ourselves. We don't get it in an API like you do in Scala. So if you took there's your functional interface for a function with 2 arguments. So it's taking A and B, returning T. Your curried version just takes an A and returns a closure that can take a B to do your overall reply. So you can see there we've implemented a function, implemented a method on an interface, which is another new thing. So the key there is the default keyword, which is another new thing as part of the Lambdas syntax in Java 8. You can use that to basically define default implementations for as many methods as you like. They can be overridden by subclasses if you want to have a whole type hierarchy of Lambda functions, or you can just use them like you would like an abstract class. So you think about them as a sort of an abstract class flipped on its head, perhaps. So where you're deferring the actual, sort of main sort of functionality of your interface to be implemented later, and you're just providing some auxiliary methods. Whereas in an abstract class, you sort of want to implement all of your basic behaviour in an abstract class and just have a little bit of specialisation in the child classes. So we can use those default methods just like this. And in fact, that's how the and then method on function is implemented as well. So we could do a function 3. We could do a function 4. And so on. And unfortunately, I've done it for you, so you could use that library that I've written if you really wanted to. So that defines functions 2 to 10, I think it was, that I did, which can be pretty useful. I think once you get past 10 arguments, you're probably using the wrong tool. You want to stop using Lambdas and think about maybe, stop using so many arguments and think about encapsulating it a bit better that's more descriptive. But yes, they're not very useful because, these sort of abstract functions aren't very useful, because you've got, your types are just A and B, or T and R, I think Java uses to note the argument and the return value. And they're not very descriptive, so when you're writing your own code, you probably wouldn't want to use these anyway. You'd want to write something that says, I take a cat and a person and something or other else, so I make a family or something. I don't know. So yeah, actually, well, that's about it really. So this is your summary. So the lexically fixed scopes, your lambdas. So I forgot to mention that. So your lambda is basically desugared into a method on the owning class. So unlike an anonymous class, it doesn't consume any extra memory. What else does it do? It has access to this. The this keyword behaves just like you would want it to. It's not this isn't the implementation of the interface that you're actually getting. It's actually the owning class, the scope of the method that contains the lambda. And as such, unlike in unlike in inner classes where if you wanted to have access to a variable from outside scope, you'd have to make it final. You don't need to do that.
I thought you still did. Did they? Has that changed?
Yeah, so you can
I've got a version of Jawbreaker kicking around somewhere, and I did have to use final to get closures in?
Yes, you don't anymore. But I think there is a special. No, it just works.
I think it has to be effective with the final.
Yeah. Yeah. So it has. Yeah. So you.
So it can't change. You can use a parameter, say, as long as you don't change it before you declare your closure.
Okay.
Yeah, so they don't have to be final, which means you don't have to put final over your code. So, yeah, method references, double colons, closures, as we showed, so we're currying, have to roll your own. Yeah, so that's actually about it. If you want more information about Lambdas, there's an excellent article. Oh, I said method references there. State of the Lambda by Brian Goetz, who basically was responsible for designing a lot of how Lambdas works. And that's the second bullet point. We're supposed to say there's a load of introductory stuff on the Java website as well, which sort of gives you a little bit of information about how to decide when you need to use a Lambda and so on, which I haven't touched on so much. So that's it. Any questions?
Does it have a new source version for the class files?
Yeah, the source version is 50, yeah, just like every version of Java, source version is 52, and you can't obviously take those back. There is a project that's doing or working on backporting through some nasty wizardry by the look of it, but that would basically, because ultimately, if you're using the just an interface with an implementation and it's all your own code, then you've got no dependencies on the core API, and ultimately when it gets desugared, you're just ending up with a class that's got a method on it that wasn't there when you defined your class, it was anonymous. And yeah, so there's a project that will basically allow you to compile back to Java 7, Java 6, I think. Yeah.
How does the streams thing interact with existing collections? Is it a fairly nice interface, or is it a little bit, you've got to go back and forth?
It's great going from a collection to a stream,
Yeah.
not so great going back from a stream to a collection. So basically, you've got, there's a stream interface, which for some reason doesn't implement iterable. I don't know why it doesn't implement iterable, especially as it has a method of iterator that returns an iterator.
Once they might throw away objects rather than.
Yeah, I guess that's
might be why. And then
that's
you've got
the idea behind. But even so, iterable is just something that can return an iterator, isn't it? So,
yeah.
and it does. So you can get an iterator from a stream. I don't know why they didn't make it implement iterable, which makes it a little bit annoying because a lot of the collections constructors you can use an iterable to construct a collection. So basically, you're forced to turn it into an array, and the construction of the array.
I think you can give it a collector and it will.
Yeah, yeah.
To the whatever the role collection.
Yeah, to collect into.
Something like that. Yeah, I didn't. It was quite unpleasant to use.
Yeah, it's not very tidy. It's a shame they didn't include things like to list and to and accept that basically this means it's going to turn into an array and put that array into an array list. So it wouldn't make sense to me, but they opted not to. Anybody else? Cool. Right. That's it. Thank you very much.